Hello everyone, myself Dr. Santanu Kundu. I welcome you all to this lecture of short computing technique. This is the second lecture of module 6. So in this module, we are discussing some numerical examples. So we are solving some questions by using genetic algorithm. So this is the flowchart of the genetic algorithm. As you know that here we need to generate initial populations, then we need to calculate the fitness values, then we need to calculate the fitness values, then we need to check the convergence criteria. If it is satisfied, then we'll get the output. If not, then we need to take the help of three genetic operators, that these are selection, crossover, mutation. Then again you need to do the fitness evaluations. So this is the flowchart of the genetic algorithm. So here we consider a problem. So consider a problem of maximizing the function fx equal to x square, where x is permitted to vary between 0 to 31. The steps involved in solving these problems are as follows. So first, step 1, for using genetic algorithm approach, one must first code the decision variable x into a finite length of string. So we need to find the uh, length of the string. So here you know the formula that a equal to 0, b equal to 31. Here we took epsilon as equal to 1. So 2 to the power n minus 1 is greater than equal to b minus a by epsilon, that is 2 to the power n minus 1 is greater than equal to 31. 2 to the power n greater than equal to 32. So n is equal to 5. So we need 5 bit unsigned integer numbers between 0 to 31, that is all 5s are 1. So the objective function here is fx equal to x square, which is to be maximized. So the having maximum value is more fitted. So a single generation of genetic algorithm is performed. We are solving one generation with encoding, selection, crossover and mutations. To start with, select initial population at random. Here the population size is 4, so we will take only 4 chromosomes. But any number of populations can be elected based on the requirement and the applications. So here there is table. So the initial population randomly selected. So obtain the decode x values for the initial population generated. So consider string 1. So here we need to consider string between 0 0 0 to 1 1 1 1. So one such string we are considering at 0 1 0 1 0. So we are considering one string, that is 0. So we are considering one string that is basically 0 1 1 0 0. So the string is 0 1 1 0 0. So if you solve it, the equivalent decimal number is 0 into 2 to the power 4 plus 1 into 2 to the power 3 plus 1 into 2 to the power 2, 0 into 2 to the power 1, 0 into 2 to the power 0. So that is 0 plus 8 plus 4 plus 0 plus 0, so 12. So similarly, all 4 string the decoder's values are obtained. So calculate the fitness or objective function. This is obtained by simply squaring the x value. Since the function is fx equal to x square, so here x equal to 12. So fitness value for x equal to 12 will be f12, that is equal to 12 square, that is equal to 144. So here similarly for x equal to 25, so fx will be x square, that is 625. So we'll solve the for all 4 populations. So compute the probability of the selection. So probability of the selection is equal to fx divided by summation of so probability p of xi, that is fxi summation I equal to 1 to n f of xi. So here the probability, the f12 is 144, the total equal to 1155. So probability will be 144 divided by 1155, that is 0.1245. The percentage of probability is obtained at 0.1247 into 100, so that is 12.47%. The same operation is done for all the strings. It should be noted the summation of probability is 1. The next step is calculate the expected count, which is calculated as expected count equal to. So I am telling you the expected count. So here is 115. So 115 is equivalent to 4 4 populations. So one population is 4 by 115. So for 144, the number of expected count is 1154 into 144. So that is equal to 144 by 1155 divided by 4. So that is basically fx by the average value. So this is known as the average. So you can write it fxi bar. So that is equal to expected count is equal to fitness by average. So expected count is fitness is 144, average is 288.7, so that is 0.4987. So computing the expected count for the entire population, the expected count gives an idea of which population can be selected for further processing in the mating pool. Now the actual count is to be obtained to select the individual which would participate in the crossover cycle using roulette wheel selection method. The roulette wheel is formed. Roulette wheel is of 100% and the probability of selection is calculated in the step 4 for the entire populations are used as indicator to fit into the roulette wheel. Now the wheel may spin and the number of occurrences of population is noted to get actual count. String 1 occupy the 12.47%, so there is a chance it occur at least one, hence the actual count may be 1. So next we will solve it. The string 2 occupying 54.11% of the roulette wheel. It is a fair chance of being selected twice. Thus the actual count is considered as 2. On the other next string is 2.16, so the occurrence next cycle is very 4, so actual count is 0. String 4 is 31.26%, so at least one chance occurrence will roulette wheel. So the actual count is 1. So try to understand the same thing by using example. So here the table which I discussed earlier. So here the 4 populations belongs to 0 to 31. So here this is 0 0 0 0 and 1 1 1 1. So take in the interval like that. So first we take it 0 1 1 0, so that is 12. Next is 1 1 0 0 1, so that is 25. 0 0 1 0 1, so that is 5. 1 0 1 1 1 1 0 0 1 1, so that is 19. So fitness value fx equal to x square 144 125 25 361. The summation is 1155. Average is 288.75 and maximum is 625. Now the probability which is equal to fx by summation of fxi. So that is basically 1145 by 1155. So that is basically 0.1247. 625 by 1155 is 0.5411. 25 is 0.0216. For 361 it is 0.3126. Now in roulette wheel that is 100%. So that is basically the roulette wheel. So here this is the 54%, so we are considering as it is 54%, so we are considering it is for sample 2, so that is 54.11. Next is 31%, so that is sample 4, so that is 31.26. Next is that 12.47, so 12.47%, that is sample 1, and this is 2.16%, that is sample 3. Now try to understand the expected count. So expected count is that fx by the average. So you can solve in this way also. For 100% it is equal to 4. For 1 it is 4 by 100. For 12.47 it is 4 into 12.47 by 100. So you will get it 0.4987. Similarly here it is 12 4 into 54.11 by 100, so that is basically 2.1645, so that is 0.0866. This is 1.2502. So this is actual count is approximate 2. This is actual count is approximate 1, so that is equivalent to 0, so we are taking it 1. This means that 2, which is 1 1 0 0, selected for 2 times, and this 4 is selected for 1 times, and that 1 which is 0 1 1 0 0 selected for 1 time. So next we'll do the crossover and the mutation with these samples. So check these things. So now writing the mating pool is based on the actual count shown in the table. So the actual count of the string 1 is 1, hence it occurs once in the mating pool. The actual count of string number 2 is 2, hence it occurs twice in the mating pool. Since the actual count of string 3 is 0, so it does not occur in the mating pool. Similarly, the actual count of string 4 is being 1, so it occurs once in the mating pool. Based on the mating pool is formed, so crossover operation is performed to produce new offspring. The crossover point is specified, and based on the crossover point, single point crossover is performed and the new offspring is produced. So the parents are here the parents. So this is 0, 1, 1, 0, 0, 1, 1, 0, 0. So we are considering this is after this point. So single point crossover. So here we'll get it P1, P2 is this thing. So C1 you will get it 0, 1, 1, 0, 1, and C2 you will get it 1, 1, 0, 0, 0. So in similar manner, crossover for other strings also that we'll show it in the next slide. So after crossover operations, the new offsprings are produced and X values are decoded and fitness is calculated. In this step, mutation operation is performed to produce new offspring after crossover operations. Once the offsprings are obtained after mutation, they are decoded to X value and find the fitness values are computed. This completes one generation. The mutation is performed on a bit by basis. The crossover probability and mutation probability is assume 1.0 means all parents are going to the crossover, and 0.01 means 1 by 10. So there is up to 100 bit will up to 10 bit will change 1. So there is 20 bit will change only 2 bit. Once the selection crossover mutation are performed, the new population is now. So that is the population after the crossover. So here I said this 2 selected for 2 times. So and this one selected for 1 times, and this is also selected for 1 time. So here do the crossover. So here the crossover. So 1 and 2 the crossovers are there. So that is 0, 1, 1, 0, 0, and that is 1, 1, 0, 0, 1. So I doing the crossover after this point. So here C1 is 0, 1, 1, 0, 1, and C2 is 1, 1, 0, 0. Then for this we are doing the crossover after here. So again we'll get 1, 1, 0, 0, 1, 1, 1, 0, 0, 0, 1. So that this the decoded value is 13, this is 24, this is 27, this is 17. So fx square is 169, 576, 729, and 289. So these are the total value, these are the average value, these are the best value. So we are doing the mutation. So as there is mutation probability 1 by 10, so we are changing 20 bits. There is 20 bits, so we'll take only 2 bits. So let these are the 2 bits we need to change. So this is 0, 1, 1, 0, 1. Here this 1 bit will change. So that is now 1, 1, 1, 0, 1. So that is 29. Now there is no change. So that is 24, 27. This is 1, 0. So this bit will change. So that is 1. So that is 20. So now this average value is this the value is total value is 2546. So functions shown from x values thus decoded. The result of the successive cycles of simulations are shown in the different tables. From the tables, it can be observed how genetic algorithms combine high performance notation to achieve better performance. In the tables, it can be noted how maximal and average performance has improved in the new populations. The population average fitness has improved from 288.75 to 636.5 in one generation. The maximum fitness has increased from 625 to 841 during the same period. Although random process make these best solutions, its improvement can also be seen successively. The string of the initial populations, that is 1101, received 2 chances for existence because of its high above average performance. When this combines at random with the next highest string 10011 and is crossed and crossover point to one of the resulting strings 1011 proves to the very best solution needed. Thus, mutation at random, a new offspring 11101 is produced which can excellent choice This example has shown one generation of the simple genetic algorithm. You can proceed for other generation also. So in this questions, we have solved roulette wheel by the stochastic process. Another example is that we can use by random number. So please try to understand these questions. So here the question is that maximize fx equal to 15x minus x square. So x belongs to 0 to 15. So number of bit is required. 2 to the power n minus 1 is greater than equal to 15 minus 0. 2 to the power n is greater than equal to 16. So n equal to 4. So we need 4 bits. So here we assume 6 solutions. These are 8, 2, 11, 10, 14 and 13. So corresponding code which is in the genotype, that is 1000. For 2 it is 0010. This is 1011. For 11, 10 is 1010. So it is 11100. So that is 1101. So fx 15x minus x square. So for 8 it is 15 into 8 minus 64. So 15 into 8 minus 8 square. So it is 120 minus 64. So that is 56. So fx is 56. That is also 26. That is 44. This is 50. This is 14. That is 26. So total is 216. So the ratio is fx by summation of fxi. So that is basically 0.26. This is 0.12, this is 0.20, this is 0.231, this is 0.060, that is 0.12. So find the cumulative frequency. So first is that 0 to 0.26. So that is for x1. Now 0.26 to 0.38. This summation of this, add these two. So it is 0.38 for x2. So again, if you add this, you will get 0.58 at x3. If you add it, you will get 0.811. If you add it, you will get 0.871 for x5. And if you add it, you will get it the x6. So that is 1. So now we are solving the, we are applying the selection technique based on roulette with and random number. So random number we calculate, that is some number from 0 to 1. So 0.153. So 0.153 lies here. So x1 is selected. So x1 means 8 is selected. Now next random number is 0.5. So 0.5 lies in here. So we took x3. So x3 means 11 selected. That is 1011. 0.647. 0.647 here. So x4 is selected, which is 1010. Now next is 0.037. So this is light. So x1 is selected. So that is 100. Again 0.341. So 0.34 here. So here x2 is selected. 0.553 lies belongs to here. So x3 is selected. So here these are participate for crossover and mutation for the next generation. So this is an example of roulette wheel selection method with random numbers. So this is a roulette wheel selection methods with random numbers. So now try to understand the next examples. So here we need to solve one question, which is that maximize fx is equal to x cube minus 60x square plus 900x plus 100. X belongs to 0 to 31 with 4 initial value, binary encoding. So we need 5 bits, roulette wheel single selection, single point crossover, 0 mutation. So there is no need to mutation. We need to solve up to second iterations. So 4 populations. So we assume 4 chromosome, P1, P2, P3, P4. So we are selecting 28, 15, 23, 4. So fx is 212, 3475, 1227, 2804. Total is 7718. So if we encode 28, you will get 11100, 15 01111, 23 10111, 4 is 00100. So total value is this thing. So this is a binary encoding. So we are selecting with the help of some random numbers. So let put all these things in the cumulative. So here you will get it just like these things. So 0 to 212, for that is P1. The random number is anything, not 0 to 1. So for P2, that is the addition of these two. So 3687. For P3, it is 4914, and this is 4914 plus 2807. So that is P4. So we are selecting random numbers. So our random number lies here. So P2 is selected. Similarly, P4 is selected. So we select P2 for 2 times and P3, P4. So P3 and P2 participate in the 1 point crossover. So we'll get C1 and C2, P4 and participate for this 1 point crossover after the second position from most significant bit. We'll get it 0011 and 0110. So now decode it. So next says this is C1, C2, it's P1, P2, P3, decode it. So this is the result. So see, the maximum value is improving. So this method you can continue for the next few iteration to get better result. So in this example, we are using the relative selection method, but not with the random number from G0 to 1. This is any random number. So in conclusion, I hope you have understood the solution procedure. So please try to solve one question. Suppose maximize the question for today's class is that maximize fx equal to 220 plus 30 by x square minus 100x. X lies belongs to 0 to 15. Take 4 initial populations. Assume 4 initial populations and roulette wheel selection method. Roulette wheel selection method. Single point crossover. And solve up to 3 more iterations. Up to 3 iterations. So this is your today's questions, and these are the references for today's class. Thank you.